Hello everybody, and welcome to the Energy and Electricity Study Guide video. Through this video I'm going to be walking people through the various aspects of what's on the sheet and also what should be expected in terms of what is going to be on the quiz. That being said, I'll run down the study guide sheet and go and try and explain as best I can for each one of these items. So, starting off with topic 1, primary and secondary classification. The main things to focus on here are the two primary categories, which are kinetic and potential. So, kinetic. What's kinetic energy? Kinetic energy is energy of now, energy of motion. So this is now, this is energy of motion. Potential would be anything that is stored, or in waiting, we like to say. Some examples of kinetic energy. This would be a, i.e. ball thrown, i.e. book on shelf. So the book is obviously supported. The book is under the forces of both the shelf pushing up and gravity pulling down. If we were to remove the shelf, the book would fall. Therefore, it leaves the potential category and becomes kinetic. Alright, scroll on down here to the next batch, which is mechanical, thermal, chemical, electrical, electromagnetic, and nuclear. We did go over these in class, but I want to make sure that everyone is clear on some examples. Mechanical would be any type of energy source that is referred to as being a change in position. So change, which can be described in the symbol of delta, change in position. So this could be a boy on a bike, boy on bike, and obviously the bike needs to be moving. Alright, thermal examples. These are nice and easy, but basically this is either a positive or negative away from whatever the standard temperature is. So if we have a room of 68 degrees Fahrenheit, hot, like hot cocoa, that would be a positive heat. And if we had ice, which obviously is less than 68 degrees, that would be a negative form of heat. So both anything that is both hot and or cold falls into the thermal category. Chemical. This is a nice easy one. Everyone loves this stuff. Food. Back in the day, people used wax to light their way. Wax is a form of fuel, a chemical fuel. This could be, let's go with gasoline. Gasoline. And also maybe some batteries, because batteries have chemicals within them that react to produce electricity. Electrical. Really no major other example other than electricity. And through electricity we can just describe it as the motion of electrons. Moving electrons. Electromagnetic. Great X-Men use violence in most rescues, and this would be the EM spectrum. And gamma rays, X-rays, ultraviolet, visible light, infrared, microwave, radio waves. So that's the EM spectrum. Nuclear. Unfortunately, we do have things like bombs that can fall into that category. But I like to think of power plants. And one of the largest power plants are stars. And we happen to have one in our own solar system here, and that would be our sun. Cool. Alright, so some examples that might show up on a quiz. If I presented apple as a food, would it be kinetic or potential? Apple as a food. That would invariably be potential, especially if you haven't eaten it yet. Once it's passing through your system and being broken down, that would be kinetic release. So we'll say potential, and we'll treat that as chemical. So primary or first, and then our secondary or second category. Now, for the apple being thrown, well, it's moving, so what is that going to be? What do you think, kinetic or potential? I'm going to go with the kinetic, I agree. And because it's changing its position, look at the list above, you are correct, indeed, mechanical. that is topic 1. Alright, topic 2, heat energy transfer, conduction. Remember, direct contact. Looking at this lava lamp over here, the item that's in direct contact, that would be this metal bar that's in the bottom of the chamber here, is in direct contact with the fluids inside, and so conduction is going to be right here, number 1. Good. Convection. Convection would be fluids, and radiation would be EM, or it's electromagnetic spectrum, or an example here would be infrared or visible light, both of which are occurring in this sample here. So, radiation, is that going to be the top box here pointing to this movement of fluids, or is it going to be the bottom box here pointing to the light bulb? Obviously, I'm sure you know this one. We're going to put a 3 down here and a 2 up here. Excellent job. Make sure you're able to go and label a lava lamp with this important information. Alrighty. Topic 3, renewable versus non-renewable. Renewable, this is anything that can be replaced or takes millions of years, so millions of years to use up. And the reason I mention that, most of you are familiar with things like biomass and biofuels and anything like that that uses current sunlight, wind, hydroelectric, and various things like that. The sun will wear out eventually, and so we do generally put solar in the renewable category, although some might debate that eventually when it's gone you can't make a new sun. So, but for now we try and keep sun in the renewable category. Non-renewable, anything that once is used, you cannot make more of it. Big ones, fossil fuels, obviously. Uranium, things of that nature. Once it's been used up, it's very difficult to make more fossil fuels and more uranium. It's not a task that most scientists have even tried to do. Alright, so, looking down here, topic 4, temperature conversions and scales. Let's bring a paper up for you on that. Alrighty, so, you have 3 main categories: Fahrenheit, Celsius, and Kelvin. Absolute 0 for Fahrenheit, negative 460. Absolute 0 for Celsius, negative 273. Absolute 0 for Kelvin. And remember, Kelvin scale was actually created to support the idea of absolute 0, so it's going to be 0. Freezing. You and I live in a world, the United States, where we consider 32 to be the cold temperature at which water freezes. In the Celsius world, aka the rest of the world, freezing is 0 degrees. And last but not least, right there is, let me just slide this back a little bit, I apologize. The Kelvin happens to be 273. Boiling, obviously 212, as you remember, and Celsius, love that. That range right there of 100, so nice, which is why the world uses it, except the United States. Because this range is 180, that makes no sense. But 273, well, Kelvin's based upon Celsius, so we're going to have the same 100 range here, and we're going to say 373. Excellent. Alright, topic number 5. Topic number 5 is asking you to discuss solid, liquid, and gas, and the amount of kinetic energy. So you should be able to quickly identify materials that are solid